Now that we've had an opportunity to take a look and review our mutually exclusive events, or our OR probabilities, next I want to take a look at our review of our independent events that have AND probability in them. Now when that is the case, such as you roll a red number cube and a blue number cube, which are independent of each other because what I roll on one has no effect on the other, then when we do that, this time we're going to still find the probability of A in step 1, then find the probability of B in step 2, but then because we want both of them to occur, which decreases the probability of it happening, we're going to multiply the two probabilities and simplify, convert to both decimal and percent. So our first one is the probability of a red 3 and an even blue. Now if I think about that, on red, the probability of rolling a 3 is going to be 1 out of 6. Oops. And the probability of rolling an even blue. So on the blue dice, probability of rolling an even number is 3 out of 6, or 1/2. So if I think about this, multiply them across, 3 out of 36, which I divide by 3 to simplify, I get 1 out of 12. So I'm going to let you go ahead and calculate the percent and the decimal, which you know how to do. The next one is probability of a red 5 and a blue 1 or 2. Well, in that case, a red 5 is 1 out of 6. A blue 1 or 2 is going to be 2 out of 6. And when I multiply those, I get 2 over 36, or 1/18. And as usual, I'm going to let you calculate them. I do want to see the decimals and the percents here in your notes to give you that additional practice. This third one is going to be a red and blue prime number. Now, if you recall, prime number is going to, 1 is not prime, it's also not composite, that does not count. Our only prime numbers on a dice are 2, 3, and 5. And so that's 3 out of 6, or 1/2 on the red and 1/2 on the blue, which gives us 1/4, which, because we can do that one easily in our head, we'll write that one down. 0.25, or 25%. Now let's get into something. Next we've got Hayden. Hayden hits 70% of the balls his dad pitches to him, and Crosby hits 35%, hence, go figure, he's 4 years old. His dad pitches to them. Find the following probabilities. So we want the probability of Hayden and Crosby both hitting a ball that their dad pitches to them. So the probability of Hayden is 70%, which I can simplify to 7 out of 10. And the probability of Hayden hitting one, or Crosby, sorry, is 35%, which if I simplify that, I can divide them both by 5, which is 7 out of 20. So if I go ahead and do this, and yes, you could keep them as a decimal, but remember you need fraction, decimal, and percent. I get 49 out of 200, which is just under 1/4. I'll let you go ahead and calculate the decimal and the percent. Next, we've got the probability of Crosby getting a hit and Hayden not getting a hit, because if you recall from the iBook, this little apostrophe here means not. So the probability of Crosby getting a hit is 7 out of 20, because it's that 35%. And if Hayden is 70% getting a hit, that means he's 30% not going to get a hit. And if we simplify 30%, we divide that by 5, we get 6 out of 20. When we go ahead and multiply those together, we get 42. Whoops. Out of 400, which if we simplify that down, we get 21 out of 200. Alright, and then we have here the probability of Crosby getting a hit and Crosby not getting a hit. Remember, these would be two separate pitches. So the probability of Crosby getting a hit is 7 out of 20 because it's 35%. The probability of Crosby not getting a hit is going to be 65% or 13 out of 20. Now if we go ahead and multiply these, 7 times 3 is 21, carry the 2, 7 times 1 plus 2, that's 91 out of 400, which I'm going to go ahead and let you guys take care of the number crunching.